All right. Good morning, everyone. Thank you for having me here in Tokyo. Um, it's been so exciting watching the excitement around observability engineering in Japan, and I was actually surprised to learn that this conference was put together in 3 months. So I'm amazed with what the organizers have accomplished, and I'm looking forward to engaging with all of you today. So Yoshi already introduced me, so I'm not going to belabor this, but I'm the field CTO at Honeycomb, and we do produce an observability solution, but that's not what I'm here to talk about. I'm here to talk instead about how you can think about delivering effective observability to your teams. So to set a little bit of context, the reason why we care about observability is because it helps us solve problems with our complex systems. Problems of outages and complexity and technical debt. And we need tools to be able to solve that. And in my view, those tools are service level objectives and observability. That those are kind of those key things that we need to make sure that the systems run smoothly. But they're not in and of themselves the goal, right? They're how we accomplish that goal. So in that vein, observability is the mechanism by which we are able to debug and understand these systems using data, right? Data coming out of our systems is a crucial element of how we in a site reliability engineering or DevOps community are able to do our jobs effectively, because otherwise it's like trying to navigate around our systems without a flashlight, without any light. But what kinds of telemetry data do we tend to use? Well, historically in the past, we've defaulted to using metrics or logs. And that's because it's what we used for many years. They're standard technologies. Many people many people know how to use them. And also, it's what our vendors tend to support best because those vendors have been around a long time and they've built their business on helping people with logs and metrics. But one of the challenges that's happened since we started adopting microservices and other cloud native technology is we have stopped being able to effectively debug production with metrics and logs alone. And not only that, we're starting to pay more and more and more money for our observability bill, and we're not getting the results that we expect. And often, a lot of people panic at this point when they see their bill going up and up and up, and they look at the cost of how much would it take to run it ourselves, and they decide, why don't we just build it ourselves? Now, that's kind of a little bit, it seems easy because we've got open telemetry for doing the collection. We've got technology like ClickHouse for storing the data. And there are any number of open source visualization tools that you can use. Or maybe you might even feel tempted to build it yourself because the hard part is just the storage and the collection, right? But is this the right thing to do? Well, I think it's important to think about what's the problem that we're solving. Or not even that, right? Like instead of focusing on us as S-Res or a platform team or an observability team, what if we thought instead about what our customers, our developers are facing, right? What they care about is trying to understand how well are their features behaving in production, and are they able to actually understand what's happening? And when we dig into this, right, like we tend to discover that developers want to have an understanding of what are individual user transactions looking like, how are their individual features doing, what changes to the code are impacting things, and none of those directly have to do with logs or traces or metrics. So we maybe need to take a step back and instead of thinking about this as far as in terms of a build versus buy versus acquire kind of problem. We can instead think about, what is the most effective way to accomplish this? And I would say one thing that I know for sure is that building something bespoke just for your own organization can create a lot of technical debt and complexity that then you have to pay to maintain forever, as opposed to having someone run it for you. Speaking of running the software, right, like that's an ongoing effort in order to keep your observability solution running if you're hosting it in-house. And if you lose sight of the fact that unless you work for a company that is that is supplying observability. Observability is not the purpose of your business, right? The purpose of your business, maybe it's payments, maybe it's e-commerce, right? Like maybe it's banking, but like we have to make sure that we are enabling the business to succeed at that. And what we do with observability is in service of supporting that, not necessarily the kind of primary thing that we're doing. So we should focus our efforts as site reliability engineers or DevOps or observability engineers on building the highest leverage things. What are the things that I uniquely can do to help observability succeed in my business? And often that's not going to be building the actual observability technology itself. Instead, it's going to be helping our organization roll out observability. And yes, there are a good number of customer-aligned vendors. And I think, honestly, any vendor can become aligned with your organization as long as you kind of take control of that relationship and you say, this is what we're trying to accomplish. How are you helping us achieve that objective? So how do we actually develop a strategy for regaining this control and thinking about how we are enabling our developers to have good observability? Well, we have to start by measuring user experiences, right? So what this means is every time that someone is interacting with the systems that you build, we need to think about what does success look like for them? How do we know whether they're having a successful time or whether they're experiencing an error or other problem? So for instance, one thing that we might think about in the case of, for instance, writing the JR rail, right, like is, every time someone taps their IC card, right, you expect it to let them through very quickly. And if it fails for some reason, right, that creates a backup in the station. It causes that customer to become frustrated, right? So we want to measure what that journey looks like, whether it's writing the trains or whether it's your online digital services. So one analogy that I like to use when describing how telemetry works is I like to talk about marbles, right? Like the toys that you have your children play with, right? And it turns out that they have many different properties, that each marble is unique, right? That they have maybe a certain size and a shape and a color and a pattern. And we can identify kind of each of these individual patterns, and then we can start asking questions, right? Which marbles have what properties? How many orange marbles are there? How many marbles are there that are less than 1 centimeter around? And this is what we can think about in terms of user journeys in our systems, right? What we are fundamentally paying to store and query when we are paying for observability is for the ability to analyze and break down those user journeys just the same way your children might categorize their marbles and sort all of the red ones into one pile. And I think one of the challenges that we have as an industry is a lot of sprawl and duplication. Because every time someone encounters a problem that they can't solve with metrics, maybe instead of trying to solve it the right way, instead they just say, we're just going to log something instead because metrics are not doing the job, so we're just going to add some logs. Or maybe they have a whole bunch of logs and they're going to generate a bunch of metrics as well because the logs have become too costly to search. But that starts adding up, both in terms of cost to store the data and also in terms of the cognitive complexity. The cost for your developers to understand the 3 or 4 or 5 different tools that you've procured. So what if we could simplify things? What if we could look at things through the lens of having just one way to look at the data and not 4 or 5 different ways? So I don't know how common this saying is in Japan, but in the US, when they first started introducing recycling programs and waste reduction programs, they talked about this idea of reduce, reuse, recycle, right? The idea that in order to be more environmentally sensitive, we needed to first reduce the amount of stuff that we were even consuming, then to discard later, that we needed to reuse what we could, and that if there was something that we could not reuse and that we could not avoid consuming, that we should think about how to recycle it. And I think that this is also very similar to how we should think about observability data. So let's start off by just storing less data. We don't necessarily need to log everything, right? If you write the data and then you never look at it, Does it make sense to have written it at all? I don't think so, right? So all of those debugging statements, right? Like, yes, all of us have put in the statement printf, I got here into a program before, and that's fine, but like we shouldn't do that in production. The other thing is often people are emitting multiple different log lines per transaction. And not only that, they're putting freeform text into their log lines. And this makes it harder for us to examine them because now the computers don't know how to make sense of, when you have a bunch of, if you have a user ID and then you've got a bunch of language and text about the user ID as well, right? Like that's extra duplicated data. So what we should really do is instead of storing multiple different things and generating 4 marbles for every transaction, what if we generated 1 marble that had all the properties that we needed? What if we created only 1 log line per transaction that contained everything that we needed? And also, all of the fields on it were clearly delineated so that we could parse them separately. Not only that, what if we could examine multiple different events at the same time that all related to the same underlying user transaction? So what if we took all of the marbles associated with a given transaction, put them on a string, and strung them together so that we could look at them all together? Or if we decided that we didn't want to look at a given trace, we could discard all of the marbles associated with that trace. Secondly, we should start thinking about sampling. Now, I recognize that people have a lot of discomfort around the idea of discarding data. But it's important to consider that not all of our data is equally useful to us. And also, we can use statistics to approximate. We can use statistics to determine after the fact, what did the distribution of the data look like before we sampled? For instance, when you snap a photograph with your phone, we don't expect your phone to save the value of every pixel, right? Your phone is approximating and averaging and compressing the values of the pixels so that it can generate a much more space-efficient representation, right? Because if I were to take a photo of this room right now, right, like the desks in front are mostly gray or white colored, right? Like we don't need to store the detail of every single white pixel. We can just say, oh, those look roughly similar. They're in the same location. So in that vein, when it comes to telemetry data, we can think about taking individual traces or individual trace spans, and we can sample. We can say we're going to randomize, and maybe for 1 in 100 of the traces, we'll keep that one. And for the other 99 out of 100, we're just going to discard it because it's not giving us additional signal. Now, why not aggregate the data? Why not try to kind of recycle the data that we've produced? Well, I think one of the challenges is when you are aggregating data, and especially pre-aggregating it in the form of metrics, it's a mechanism for getting simple answers to simple questions. It destroys the cardinality. It destroys the number of unique values associated with every event that's going through your system. And just at the end of the day, if you can think about, if you had a bunch of marbles, if you wanted to figure out how much of each color of marble there was, you could absolutely feed them through a grinder. And you'd have a bunch of piles of colored glass, right? And you could say, this is how much red colored glass I have, or this is how much yellow colored glass that I have. But you can no longer get the original marbles back. You no longer can actually know how many marbles were more than 1 centimeter wide, because that information has been destroyed in the process of creating that analysis by color alone. So in my view, aggregation is a last resort rather than a first resort. Instead of reaching first for metrics, we should reach last for metrics, only when there is something that is so voluminous and where we need an exact count of how much of something happened, and we know in advance that we're not going to need to break it down by some other dimension. So overall, we need contextual data to be able to debug our systems, and therefore logging and tracing is the most effective way to do that. So how can this sampling be cheap enough? How can we use sampling to achieve this outcome? Well, one way is that we can adjust the number of events that we get based off of how many we had most recently, right? Obviously, you want to know if at a time of low traffic, how much traffic there was, and also how many errors there were, even if there were not very many successes and not very many errors. So what we can do is we can do target rate sampling. We can say that as the load in the system scales up, we're going to increase our sampling rate. So instead of maybe sampling 1 for 20, we might sample 1 for 100 when we're getting 5 times as much traffic. And that way we get a predictable amount of consumption of our logging and tracing budget. Because that predictability matters, because we have to adhere to the economic constraints of our systems. We have to make sure that our observability cost does not overcome the cost of our cloud bill or the cost of the number of developers. But how do we avoid throwing away important data? Because every customer is unique, right? Every single user is having a unique experience. And regardless of whether it's which prefecture they're in or what kind of mobile phone they're using or what kind of payment card they're using, right? Like each customer has something unique to the transactions that they're generating. So what we can do is we can try to keep a representative sample of that data. We can try to say, I'm going to keep at least some transactions from someone who's using one of the less used payment cards. Or I'm going to keep at least some of the transactions of people who are running very old build IDs, even if the majority of people are running the newer build IDs. And we can sample away the redundant data, the data that is very highly represented in our system. Because the majority of traffic through our system is going to be successful traffic. In Japan, it's going to be customers that are using Japanese. It's going to be, predominantly traffic from people who live in cities, right? So we can say for those transactions that are very redundant, we can maybe just take a few representative samples. And then the rest we can say, they're accounted for with the samples that we did choose. But what we definitely want to do is we want to maintain all of our errors and all of our slow queries. Unfortunately, because instrumentation is code, because telemetry data can be processed and buffered and batched, we can actually say, I want to conditionally keep our data. If this transaction was slow, I want to keep it. Otherwise, if it was fast enough, I'm just going to keep only 1 in 20 of it. Now, yes, this does get a little bit difficult when you're talking about distributed systems and distributed transactions. But I think overall, the important thing that you should know is that it is possible to do tail-based sampling. It is possible to do this kind of dynamic sampling based off of both trying to achieve a target rate of events that you're keeping, and then having that number vary depending upon the traffic that's going on through your system and how many errors and how many successes that you're having. So how do we implement these practices in our organizations? How do we reduce our telemetry cost and also achieve better results with better understanding of our systems? I think one thing that we need to do is we need to keep in mind that telemetry data is not equivalent to understanding. We can keep all of the telemetry data in the world, but we may as well have thrown it in the rubbish bin if we can't actually use it to analyze our systems. There's been so much focus on, logs and metrics and traces and all of these various kinds of telemetry, but I think that they're useless unless we can actually ask questions and understand what's going on. So yes, the data is important, but the ergonomics of how we create the instrumentation and the structures with which we use to query them are just as important. Now, one thing that I think has gotten a lot easier in our space is the ability to share tooling and code, the ability to examine our data through the right lenses and to be able to get shared state on what's the trace ID, what's the request ID, how do I emit this data in a consistent fashion, both to my business intelligence database and also to my observability tooling. So OpenTelemetry is one of those tools that helps us get common APIs for interacting with our telemetry and common semantic conventions for describing what does an HTTP status code look like? How do we delineate that in our system? How do we delineate a user ID in our system? How do we delineate a browser or user agent in our system, right? So that we have consistent ways to refer to this data and to query it. So I very much encourage you to engage with the OpenTelemetry community. right? Because we as the OpenTelemetry community are a vendor-neutral framework for producing and transmitting telemetry data, whether it's in the form of a log or a trace or a metric, regardless of what programming language that you're using, regardless of what language frameworks you're using as well. And all of OpenTelemetry is supported both by end users, by vendors who are working with OTel, and by the Cloud Native Computing Foundation. And we've gotten so large now that we are now the, I think, fourth most popular open source project in the world after PyTorch, Linux, and Kubernetes. So I think we're in pretty good company there. So work with us because we're always eager to have your feedback, and chances are that someone else has run into something similar along the way in case you encounter any bottlenecks or any trouble with adoption. So what does success of a observability effort look like? I think we need to understand, again, going back to the beginning of the talk, what are we trying to achieve? What are our objectives? And our objectives are to have our developers be able to understand and debug production quickly to minimize impact to users, and more importantly, to be able to ship code faster. To me, I think success is not just can we debug as SREs, it's are we proactively using observability in an observability-driven development flow, right? So that I, as a developer, could know once my code reaches production, is it actually behaving the way that I want it to, and am I seeing good adoption? So production excellence is the goal, and that means that we have to define service level objectives and that we should use our observability data in service of those SLOs. That if we have SLOs that are tied to observability data, then it means that if something goes wrong with our SLOs, we can very easily identify where is the problem using that same observability data rather than having conflicting data. Because conflicting data that says users are having a problem and then you look at your system and you can't find the problem, that's not very helpful to anyone. And we have to make sure that we're rolling this out successfully to teams. So this means that there are many different players involved, right? That we have SREs, that we have platform engineers or observability teams, and we have the product teams that are consuming the functionality that we're providing to them, whether it be something that we wrote ourselves or whether it be something that we're working with a vendor to roll out. So we have to make sure that we have a community of practice around observability so that people know how to use the tooling that we've developed, and that we have these common goals of what does good telemetry look like? What does coverage of our system look like? How are we building in observability into our team culture? For instance, you might want to have observability be part of your production review process. Before you commit a change to your code base, have you documented what changes you made to make the code that you added observable? And even better, is there a link to a graph that you can look at so that when the code reaches production, you can see, I expected this number to go up or down after the code rolls out. And no adoption effort can be successful without people who are end users, right? People who are developers advocating for it. Because at the end of the day, maybe there will be 5% or 10% of your organizations that is SREs or observability engineers. But we cannot instrument people's code for them. We cannot we cannot look at all of the graphs for them. We cannot even make people add instrumentation to their code, right? They have to champion it themselves. They have to see the value and to share that knowledge with other people. Because otherwise, we're just going to be stuck only being able to work directly rather than through other people. So grow your community within your organization. And I think in that vein, it's important to talk about people who might be resistant to the change, people who are used to using the previous generations of tools, people who are perhaps, the most senior person on the team who understands the old observability stack well. But it's important to remember that those people deserve to be able to go on holidays. Those people deserve to be able to work on their own project work rather than constantly answering questions from junior developers because they're the only ones who understand the system. So you have to think about how do you transform someone who is maybe a detractor of your new observability effort and turn them into a champion? How do you persuade them that the new way of doing things is not disruptive to what they're doing, and instead they can be a key part of how the new generation of observability rolls out? So you have to make sure that you are accommodating their workflows in your new observability solutions, and that you are also showing them how they can accomplish so much more rather than having to kind of be the one person that everyone's knocking on the door of or who they're getting phone calls from. And it's not just SRE and observability teams that have to work on this. It's also security, compliance, and finance who care very much about observability. Because what if we could also use our observability data for compliance purposes, right? We don't necessarily have to have a separate business data store or a audit data store and an observability data store. And we all care very, very much about the cost, right? So how do we make sure that people understand that the newer generation of observability, yes, it's an investment, but it is an investment that you can measure the return of, and also that you can bound how much it's going to cost. Another thing that I see people make the mistake of often is that people try to roll out observability across their entire organization all at once. I think that's maybe a bit of a mistake. Instead, we should focus on delivering quick wins more easily by starting with individual teams and adding instrumentation for those teams, enabling those teams to use the newer observability tooling first. And that way people see the value right away, and then the teams next to them will get excited and you can add them to the tracing, right? As opposed to if you're trying to roll out tracing across your entire organization, you have to wait for all of the tracing to roll out to all of your services, and people have to do all of this extra work before they see any value. That's not going to go very far. So instead, we need to say, we're going to define success team by team rather than across the entire organization. And as people see success, they will naturally come on board with your effort. So when we're thinking about the overall OpenTelemetry journey, right, about this journey of moving away from proprietary vendors and towards freedom and flexibility of using whatever tooling makes sense for you, first you have to add OpenTelemetry to your applications automatically, and then you can start customizing that data by adding some structured data, by filtering and adjusting your existing data to make it conform to the semantics. And then finally, rolling out to potentially be able to have the freedom to switch vendors, to be able to audit and store all of your data and sample only some of it. But when you're working initially on a smaller set of services, you don't necessarily have to think about the sampling story if it's just a small amount. So automatic instrumentation really gives us a lot of value because it helps teams get started quickly and seeing data out of their services. And it gives us that baseline data, at least at the request layer. But it's up to us to add in the business value, right? We might get the IP address or the request URL and path or the status code out of the box. But we do need to think about, even in the case of automatic instrumentation, what do we not need, right? Because, for instance, we might use Redis or key-val caches in order to optimize our services. But it would defeat the point of having a cache to generate very noisy instrumentation every time a request succeeded against the cache, right? We only care about failures to fetch from the cache rather than successes. And we can think about converting logging to attributes, initially either by having those having logs attached to the trace spans that they came from, because OpenTelemetry provides this rich context. It provides us with this mechanism of identifying what's the current request going on, and then attaching any attribute that you add to that trace span, and also any log that you add to that trace span. And that means that over time, you'll be able to reduce the volume of individual logs flowing through and be able to query across multiple different logs or attributes that happen in the course of a single event. So that helps us make the logs machine readable and start asking questions like, how many traces did this event happen in that also have this other attribute? And if you're not able to modify the application code, that's okay. The OpenTelemetry collection mechanism allows transformation using the OpenTelemetry transform language. So OTel collector is very, very powerful, and it's kind of the cornerstone of any effort to roll out observability because it enables us to manage the configuration. It enables us to transform, filter, and write to many different destinations, and it can run both in an agent mode and in a centralized collector fleet mode to enable us both to do the per node agent work as well as to do the centralized routing and transformation. And yes, you can configure sampling inside of the OpenTelemetry collector rather than inside of your application code, which means then you don't have to modify your application. And you can start doing at the whole trace level that sampling rather than only doing sampling at the individual service level. Now, again, it's possible to do with very powerful tools. It's also possible to misuse them. So as I said, right, like don't over-instrument every cache call because that will generate a lot of noise and overhead. Similarly, while I said you don't have to start off thinking about sampling too hard if you're just rolling out 1 or 2 services, you also want to be proactive about thinking about sampling before you get a giant bill that you wanted to avoid. And you have to involve teams even that are not part of your initial pilot to make sure that your telemetry system is going to be able to meet their needs in the future. So as an organization, you can start off by working with one set of services and then expanding up and down the stack to adjacent services so that you don't break the trace context. And then over time, you can enable people to self-service adopt and opt into your both instrumentation and into the observability tooling that you're sending that instrumentation to. And alongside that, it's important to be able to roll out the collector fleets so that people have a default destination that telemetry goes to, that you're auto-instrumenting your applications. And then over time, you will add that custom telemetry, adding attributes and structuring your logs and sampling. And over the course of this, you also have to validate, do the traces you're getting out make sense? And is your observability tooling fit for purpose, right? Because there are 2 facets to this, right? There's both the rolling out of the telemetry collection and management, but there's also what are you doing with that data? Are you actually feeding it to a tool that makes sense for your users? Are you trying new tools all the time to make sure that you're always using what's best for your users? So today we talked about 3 things. We talked about the overall strategy of thinking about what are our goals for observability and how might we fulfill them? How does it fit in with, how does observability fit in with instrumentation and service level objectives and our business goals? We talked about tactics for how we reduce the cost of observability and increase the value we get out of it by deduplicating data and structuring it, and ensuring that we are getting the most effective data with sampling. And then finally, we talked about strategies to make this successful in your organization and to have people adopting the observability tooling that you're trying to give them. So overall, I encourage you very much to think about observability as a data problem, as a data analytics problem, and to think about how are we getting the most value for our investment rather than treating this strictly as a pure cost reduction play, or treating this as yet another migration that people have to do. So that's all that I have for you. And I also wanted to note that while I did have some help from AI in creating some of the text on the slides and creating the overall structure of the presentation, all of the art in this was drawn by a very lovely human being because I believe that art should be made by artists and not by machines. So that's it. And I'll now take your questions from Slido. Thanks.
ご清聴ありがとうございました。それではただいまより Q&A セッションに入ります。
First one? First one is in English. So when we feel that a vendor proprietary features are superior to the OpenTelemetry, do you still recommend to use OpenTelemetry over that?
I think it depends. If you have the vendor SDK is working well for you, then I think, over time, OpenTelemetry will get more and more features and will accomplish some of that automatic instrumentation or front-end observability or like other things that are perhaps less well covered by OpenTelemetry that a vendor might cover better. In terms of the backend, I think OpenTelemetry gives you the flexibility in case something better comes along, and it also gives you leverage if your vendor starts just telling you that they're going to charge you twice as much money, because now it means that you're not stuck with them and you could choose to leave. Because even if a vendor's proprietary features are very, very good, they might not be worth paying 2 times or 3 times as much money for. So having that flexibility helps you down the road.
The next question is, if the telemetry strategy is to record the slow events or errors, say, for example, in the case of network issues, the event would be explosive. And then do you have any suggestions to pick the preferred events or errors to record in that case?
Yeah, so I think that goes to the question of nesting your target rate sampling and your per key sampling based off of errors. So you could say, yes, right, like I do want to try to keep one of every error as long as my total event budget is accounted for. But if I exceed my total event budget, then I might have to start sampling errors, although I might sample errors less aggressively away than I would my successes, right? So it's kind of a matter of configuration of your pipeline to do the target rate sampling in the right order with your error versus success rate sampling.
So even if starting from the team for the observability, there's still learning cost to learn OpenTelemetry, and then how do you balance between learning curve or learning cost to learn OpenTelemetry versus using existing vendor solutions?
Yeah, so again, that splits into 2 parts, the instrumentation part and the use of the vendor technology to analyze part. For the instrumentation part, I encourage people in general, whether you're using OpenTelemetry or not, to have some kind of a wrapper around your instrumentation library. Because when you add that wrapper around your instrumentation library, you're doing 2 things. You're making it so that your developers only have to learn that API and they don't have to learn, both the vendor API and the OpenTelemetry API, or even one or the other, right? Because you've configured that out of the box to work with your organization's semantic conventions, right? And having that wrapper helps you consistently record what's the client, what's the customer, right? Like, or what's the application version, and these things that you want to have common standards for, regardless of what the underlying technology is. I think the second thing around learning new vendor tooling, again, right, like that's why I talked a lot about kind of proving value early on and kind of getting people to attest that the effort required to learn the new tooling was worth it. Because if it isn't, you shouldn't be rolling that out more broadly, right? So I think it's important to make sure that the tooling that you're using is the best for your organization.
Question is in English.
Yeah, I think the best recipe for working with your telemetry data is to look at it when you're not in an incident, as well as when you're in an incident. If you only look at production when it's broken, then you have no idea what's normal and what's not normal. So I think getting practice with working with your sampled data, or even your end sample data when things are normal, right? And you can see and say, oh, right, like that log entry is spewing a lot of logs. Maybe I should turn that off, right? You're not going to think to do that in the middle of an incident because you're busy debugging. But when you make it part of your normal operations to stop logging things that are noisy or to sample or to change your sampling strategy, you can do it when everything's normal and steady state rather than when everything is broken or on fire.
A couple of questions. So the person who questioned this thinks that Japanese developers do not care much about business as a whole, and then they develop the applications independently from the business cases. And then is it common in US as well, or what do you think about it?
I think that depends a lot upon the organization. Definitely, there are large enterprises in the US where development is viewed as IT is viewed as a cost center rather than a profit center. I think the mindset change that's required, regardless of what country or culture or size of business, is to think about IT as something that is part of how we all deliver value in the digital age that we're in, where everything is mediated by our phones or by our computers, right? So if we invest in IT as a strategic thing where the developers are thinking about the overall business outcome, that generates better results because it makes us much more responsive to our users. So I think definitely, yes, that is a challenge, and I've seen it in the US as well, but it's typically in kind of larger organizations rather than being kind of a thing that's true of all kinds of organizations. And I think that, at the end of the day, either it requires a change in leadership for people to adopt the idea of investing in IT as a profit center, or it is an outcome of competition that organizations that are faster and that adapt more quickly will have the resources to hire more developers, right? And that becomes a positive cycle.
So 時間ですね。11時まで Okay, so we have 10 minutes left. So how do you differentiate the use cases of the traces and the profiles?
That's such a good question. I've been thinking about this a lot. What it boils down to is traces give us data at the individual request level. And historically, profiles have been a per process, right? Per application, or even potentially per Kubernetes pod, right? But per deployment type of concern. So the profiling data gives us information on which functions are hot, which lines of code are hot, but it cannot currently tell us anything about which users are triggering that behavior of hot functions. All it says is this is a really busy section of your code base. What I think the future is combining traces and profiles together. What if we could zoom in past a single trace span and see the hot sections of code that resulted in that trace span running longer for that specific user, right? I think that would be such a great goal over time. But right now, a lot of this technology is either this whole process, I'm going to try, it's running hot and I need to make it run faster, or I'm trying to save some money. And then tracing is used instead for the kind of per request. How does this flow through multiple different services?
Thank you. Next question is, what do you think about tail sampling?
What do I think about tail sampling? I think it's great. But it has a cost, right? The cost of tail sampling is you have to buffer the trace data in memory for as long as your typical longest running traces. So for most of my customers, they're buffering 60 seconds of trace data. And that means that they have to run enough collectors or equivalent functionality to the collectors. At Honeycomb, we call it refinery. We run tail sampling collectors that have to have enough memory to store all of that telemetry data for 1 minute. So yes, tail sampling helps us get really excellent results on the back end as far as having querying be fast, having it not be super expensive. But it does have the operational cost of now you have to store the data for the duration of a single trace.
Thank you. Next question is in English, but this is really common, I guess. So reducing telemetries is quite difficult in the case of the legal restrictions.
Yeah. So you definitely, In the case of reducing what you're sending, I would argue that a log line that says that you got to a particular function, not useful for security audit. I do think you do need to keep records of every request for sure for your security audit. However, that data does not have to be stored in your fast observability backend. You can write 100% of that data to commodity object storage like S3 or like Google Cloud Storage buckets. And then you can, right, this is the beauty of the OpenTelemetry collector. The OpenTelemetry collector lets you receive 100% of that data coming from your application. And then it can route both 100% of that data to S3. And also it can route, 5% of the data to your observability solution. So I think that's kind of the best way to accomplish this is use the same telemetry source, but then use the collector to fork the audit stream versus the observability stream. Cool, we still have 5 minutes.
Okay, so next question is, when it comes to internal advocacy of SRA and observability, do you have any ideas on the most effective way or most convincing way to show it?
I think any vendor can make a demo on their own data look good. People only actually believe that observability is helpful when they see it on their own data or the data of someone within their organization. So I think building a really effective use case or demo of your own organization's data and to show people this is what it looks like in the older tooling, this is what it looks like in the newer tooling. Look, see how much better it is, right? See how much faster we can debug it. I think the number one thing that helps people adopt, I swear, is when you are having an incident and you are sending messages back and forth in Slack, or maybe you're on a incident bridge, an incident phone call, to paste a link to the new observability tooling and saying, this helped us find the problem. That is what gets people to want to go, oh, they solved that really quick with that tooling. I wish I had that tooling for myself.
Next question is, the person is struggling with using OpenTelemetry because of the old version of programming language and framework. And then the person would like to know the impact of using OpenTelemetry for their observability when they upgrade those languages and the framework. And then what would you do going to follow?
Yeah, so definitely it is the case that, for instance, I know PHP has this problem, Spring Boot has this problem of the older versions have OpenTelemetry supports less well. So I think over time, as you start upgrading your dependencies, you'll get better support. In the shorter term, though, you might need to add custom instrumentation. You might need to do your own creation of the trace bands and your own context propagation, right? I think that's where your developers should not need to worry about that, right? The burden of that is on us as SRE or observability teams to provide something that works for our organization and to update it to our organization standards and to maintain it as our organization rolls out new versions of libraries.
I think next question would be the best question for you. So these days, the usage of AI has been adopted a lot in the case of, especially in a situation of the development. And then what do you think about how AI can help the observability?
Yeah, so there's a lot of code out there that uses OpenTelemetry. And therefore, AI knows how to add custom attributes with OpenTelemetry very, very well. AI can help us change log statements over to OpenTelemetry trace attributes. So I think AI, right, like it is both a blessing and a curse. The blessing is that it lets us write a lot of code. The curse is that it lets us write a lot of code. But AI can also help us instrument that code and to get effective results out of it because it's helping us along the way rather than purely just adding new code. You just have to tell it, hey, I use OpenTelemetry, or what's your observability plan, and it can fill that in.
4 minutes left, so I think the next question would be the last one. how should we approach the infrastructure cost of observability, considering both the scale of the service and then the level of data sampling frequency?
Yeah, I think that is my boss, Charity Majors, who is one of the other authors of the Observability Engineering book. She and I looked and saw basically most organizations are spending between 10 and 30% of their infrastructure budget on observability. I actually think people shouldn't be measuring it in terms of infrastructure costs. People should be measuring it as a function of fraction of developer spend, right? That you pay for developer productivity tools. And to me, observability is a developer productivity tool, not an infrastructure tool. But overall, right, like I think, deciding what is our budget, how much money do we have to spend, and what's the potential gains or losses from, good observability, lack of observability.
Well, thank you for a lot of questions and answering those. So time is up, and we really appreciate your keynote, and then I hope you enjoyed the whole day today.
Yep, I look forward to it, and I think there's a book signing later, so if I didn't get to your question, feel free to approach me at the book signing, and I'd be happy to answer.
じゃあリーズさんに最後に大きな拍手をお願いします。